So this is a lesson today about linear motion. This is a lesson today about linear motion, and we talked about having jokes about airspeed velocity of unladen swallows, and we couldn't decide whether to have it in. And you know, I think we had more yeses than nos, but it was close. So probably better to skip. But I guess we could have just also explained the joke. We could have just like had this be a nice little culture sharing moment at the time. Anyway, yes, I agree. High culture, as Guile says in the chat. So yeah, welcome everyone, letting people filter in and join. Usually that happens just over the first couple minutes here. We have honestly one of our biggest crowds ever for one of these events, and so really excited to do this. This is one of our drawn together events because it's a partnership event between Sketchy and Blueprint Prep. Get it? Drawn together. It's like a team thing. Probably you get it. All right. And we're going to cover physics because every single time we ask what topic people want to cover, they say physics, and we listen to the people. If you would like us to cover topics other than physics, you need to bring your friends to these events. And then when we do a vote, you have to say that you want to do something other than physics. Until that, we aren't going to do physics literally every time. That's the reason why we keep coming back to it. We've done a few of these. So we're going to dive right in. I love to get one other thing to see in the chat. I want you to put, if you are familiar with Sketchy, you know what Sketchy is and what we do. Give me a 1 in the chat. And if you don't know what Sketchy is, or you're like, wait, what is this thing? Put a 2 in the chat. Ooh, boy, oh boy. Love this division. Awesome. Man, so what a cool, diverse group we got today. So I was going to say the people who gave us a 2, you're going to learn something today. Everyone's going to learn something today, to be completely honest. But you're going to learn what Sketchy is today as well. We're going to get in here. I thought I saw someone put 0 actually, which I guess means like maybe they work for us. We're going to get in here and talk about our group today, who's going to go through this linear motion lesson, and also just do some Q&A and hang out for a bit. So I'm going to go around here, and I'll just start with myself. My name is Adam Gray. I'm the head of med and pre-med education at Sketchy. I've been working in test prep and especially MCAT, but also tons of other exams for a very long time. And each of us is going to share, if you got eaten by a reptile, which one would you want to get eaten by? My answer to that question is a call out to Brittany, who is also on, as I believe, Sketchy Marketing, who has alligators in her neighborhood. And if I'm going to get eaten by a reptile, I'll go hang out in Brittany's neighborhood and get eaten by one of the alligators. Just apparently it's rolling right down her street because she recently moved to Florida. Also, I'll answer one question before we go to the rest of the introductions. This is important. Katana asked, how long is this? And we're going to be here for probably 45 minutes to an hour. Depends on how many questions we have. Typically, the Q&A kind of varies, and we just kind of stick around until we get through all the questions. But I'm going to hand it over to Ricky. Tell us a bit about yourself.
Yeah, so my name is Ricky. I'm an associate creative director at Sketchy. My background is in undergrad biochemistry and education. So finding this job was kind of the best blend of all of them. And if I was going to get eaten by a reptile, I would pick a Komodo dragon. Although I did just learn very recently that the whole thing about their like bacteria being like really gnarly and like takes down their prey is not true. And it's just like the same as any carnivore. So slightly disappointing. I know, Hunter, I feel like I just crushed your soul.
That's so lame. We're just a normal person.
Yeah. I know, I was very disappointed. But yeah, science has let us down in that way. But I feel like that would at least go quickly. So Komodo dragon's my answer.
All right, well, you know, if we're just dispelling animal myths today, I have to say I was also a little disheartened. I was looking up fast animals in order to pick in background for myself today. And if you don't know why I picked this as one of the animals, I'm just going to leave it a mystery for at least a while, maybe the whole session. But it turns out it is in dispute as to how fast the fastest fish are, because their speed, and this is physics related, I swear, because their speed underwater, physical speed underwater, is eventually limited at an upper bound by cavitation and like turbulent flow.
That's awesome.
So like we actually don't know how fast the fastest fish are, because some people are like, they can't possibly go faster than like 20 miles an hour. Really interesting.
This is crazy. This is the second time that physics and fish have come to my attention just today, which is today. Okay, so my partner is a marine biologist, right? And let me just pose this question to y'all. Do you guys know, it's physics related, how come scuba divers have to fall out of the boat backwards?
I hope somebody in the chat knows. I don't know. Anyone here at the event know why scuba divers fall backwards?
Something to do with pressure. That's a really
Natalie says you don't have to. It just helps.
Nicole actually got it, because if they fall forward, you're still in the boat. And on that note, hey everybody, my name is Hunter and I love dad jokes. Hey, what's up? I am the representative from Blueprint and we are super happy to be here. Love Sketchy. Everyone on this call is great. Me and Adam have worked together for years and years and years. So like, yeah, this is a good time. It's just a reunion of a bunch of friends. So like it says underneath my picture there, I'm an instructor, a tutor, all around kind of content expert. I help Blueprint with their marketing stuff. So like, sorry if y'all see the commercial of me on YouTube or if I'm invading your podcast, that's my bad, blame Blueprint. But yeah, other than that, I've been teaching for about like 9-ish years, a lot of gray hairs now that I didn't have back then. Right after college. So I went to Arizona State University, got my bio degree in biochem, and started working for a nonprofit that taught science to children. I was basically Bill Nye in Arizona. It was really cool. And then I took my MCAT and I realized I didn't want to go to med school and I really like teaching. So I avoided a whole bunch of debt. And then with that, oh, get out of here, Nikki. Tucson just wishes that it was too Tempe. With that, now I'm hanging out in California. I'm so sorry, Nikki. You're amazing. I actually have no qualms. I've never been to a sports game in my collegiate career. So you know what? Tucson's wonderful. But yeah, now I live in California. I teach MCAT prep every day. It's awesome. I also used to be a death metal vocalist, so that's cool. And it's also influenced my decision on what reptile is going to eat me. I want to be eaten by not just any reptile, but like one specific one in particular. Jormungandr. It's the giant snake in Norse mythology. And if there's one super brutal metal way to go out, it's being eaten by a snake that's the size of like the planet. So like, yeah, that's what I'm going to do.
All right. So last but definitely not least, especially given the awesome physics related nature of our content today, Kyle, tell us a bit about yourself. Thanks for coming by today.
Good afternoon, good evening, depending on where you are. Maybe good morning. I don't know how many people we got on other sides of the planet here today. But my name is Kyle Waters. I am a physics faculty author for Sketchy. I am a faculty member at California State University, Sacramento campus. I have been teaching physics for a little over a decade now. I got my PhD in astrophysics from Stanford University, where I studied young neutron stars. It is exactly as awesome as it sounds, which is very awesome. Now I teach at Sac State, and I also run the planetarium at Sac State, which is a lot of fun. So I kind of have my fingers in two different fields, right, with physics and astronomy, keeping busy with both of those. And then staying a little bit extra busy working on physics sketchy sketches, which is a lot of fun. We've got a great one for you guys today on linear motion, but I just absolutely love physics. I am admittedly an enormous nerd. I actually double majored as an undergrad in physics and computer science, which I think are arguably like the two most stereotypically nerdy things you can study. And so I'm going to seem really excited today, and that's not me faking it or trying to do it for you guys. I actually just really love this stuff. And so you might have to, stop me from talking about physics, because Adam said 45 minutes to an hour, but really I feel like we should do this for like 3 or 4 hours tonight together. But I was voted down on that. And my reptile.
Next time.
My reptile, I was giving this some thought. And you know what I'm going to go with? Because we didn't make any rules about whether the animal needs to be extant or not. And so I'm going to go with Tyrannosaurus Rex, because I don't know exactly what would lead up to me being eaten by a Tyrannosaurus Rex, but I feel like it's an epic story, and that's a way to go.
T-Rex is a bird, not a reptile, Kyle.
Birds are reptiles, according to the cladistics biology people that I was reading on Reddit.
Oh man, now
It was on
that
Reddit,
I cannot
Adam.
handle. That I cannot handle. All right. Wow, yeah. They say falcons are dinosaurs. At least that's all I know.
Yeah.
So To get into the meat of things today, what we are going to cover over the next little bit of time is we're going to spend just a little bit of time talking about Sketchy and Blueprint, because as you all saw in the chat just a moment ago, we do want to orient you to what it is we do, but that'll be pretty quick. Then we're just going to dive into our lesson on linear motion, which is going to be, as you might have gotten a sense, themed with some, you know, amphibians, reptiles, dinosaur type things. And it's going to be a story that teaches us all those really tough things you learn the first few weeks of physics class. And then a couple weeks later, half the class is gone because everybody gave up. But you're not going to. So then we're going to do some Q&A. There've already been some Q&A in the chat, and that's awesome. And we're going to cover those at the end. We'll use the Q&A function. And I want to tell you, there's going to be a giveaway at the end as well. So Sketchy and Blueprint, we do this little bundle thing together. We're going to give away one of those. So make sure you stick around to the end so you can potentially get one of those things for free. But let me talk a little bit about Sketchy. What is Sketchy? Well, we do stuff like this. This little picture you see is our lesson on the sympathetic nervous system. We're a visual learning platform. And yes, of course, the sympathetic nervous system lesson is at a bar called Fights and Flights. That makes perfect sense. And we are used by tons of students. We are especially used by medical students. And we are much more recently here going to MCAT students as well, because, well, the same folks. We're just talking to you a few years earlier. And our method of learning is especially effective for really tough memorization-based topics like microbiology and pharmacology, like you have to run to in med school. But as it turns out, learning as a whole is just a change in long-term memory. That's just kind of what it is. So you want to learn anything, but you hook it into things like visual learning, and not just visuals, but also stories and settings and characters and drama and humor. These are the things our brains are wired to just remember more easily. And so that's what we do for you. So we get this question a lot. Am I the kind of person Sketchy would work for? And oh, you can see the stuff on the screen here. But what I'm going to say is, unless you have aphantasia, unless you are one of those very rare people who does not have a visual imagination, which is it doesn't mean you're bad if you have that condition, but unless you do, Sketchy is something you should check out. And of course, you can just sit where you are in order to check it out. But about Blueprint, Hunter, tell us a little bit about what you do in your neck of the woods.
Yeah, so we're like kind of two sides of the same coin, right? And that's why like all of us kind of partnering together makes so much sense. We do, as opposed to like very visual heavy, like in individual like lessons, and we're going to teach about like the specific science. Ours is kind of more of like, you got a class type thing. So it's the whole classroom. It's customizable to you with our study planner tool, which, I mean, that's alone. When I was studying for the MCAT, I wish I had that. It's the one thing that makes me really bitter for my current students. You just put in a bunch of information, a bunch of like, hey, how many hours a week? When are you going to start? When's your test? What days are you unavailable? And it builds an entire plan that's just like, hey, this is what you should be doing on a day-to-day basis. So gets rid of a lot of that stuff. Our exam's super representative. If y'all have been on like Student Doctor Network, r/MCAT or anything, and you've heard, oh, Next Step exams, they're amazing. We are Next Step. We've been Next Step for years now. And then feel free to reply to those comments and say, hey, Next Step is Blueprint. Their exams are the most representative. And yeah, I mean, we just got a bunch of good stuff. We got a whole bunch of 99th percentile instructors. Hey, what up? That's me. That's our tutors and our premium tutors. Other than premium tutoring and stuff like that, we can also do, like I said, whole courses. Go to the next page. We do whole classes. This is everything. Woo. There's 2 instructors in every one of our classes. There's QBank flashcards. Like it's an entire like comprehensive all-in-one. Like if you start from start to finish, you're going to be ready for the MCAT. Plus, you get to hang out with people like me. I have a class that's starting at the end of June. So what up? Come hang out. And then how representative is the half length, full length? It is 100% representative, but only 50% is long. So there you go.
Wow, that's extremely concise summary and answer to that question. Thank you, Hunter.
Efficiency. It's just being smart and lazy at the same time. It's mwah.
That's what the good old guidelines for leadership from the Army used to say, right? The people who are clever and lazy are qualified for the highest levels of command. I'm just going to go with that. These are things I pick up in being a random nerd around the world. Anyway, we're going to talk through a physics lesson. And this is where it fits into the grand picture of Sketchy. As you can see in the little drop down, this is like a screenshot from our product. We have lessons on every topic of every science subject in the MCAT, plus some on MCAT strategy and some that show how to apply learning through Sketchy into MCAT passages. But our physics course is one of our most popular. And we're going to see some of it today. We're constantly adding to it as well. There's actually several more coming out even just next week is the plan. But I don't want to spoil that too much. This, however, is our lesson on linear motion. And let me set the stage. We are here in the medieval fantasy styled world of lots of different animals that act like humans. It's a really original idea that nobody's ever thought of before, is what I'm saying. And in this case, everybody who is involved in kinematics and linear motion and motion in general, we theme everything with reptiles and amphibians. We kind of have this, thing going on. And Ricky, I want to hand it over to you to talk about this first little character who just showed in and what information he represents, or she. Not really sure the gender.
Yeah, no one knows. That's the beauty of it. Yeah, so this is showing that linear motion means that an object's acceleration and velocity is in one dimension, because once you start getting like a vertical component and a horizontal component, then you're in projectile motion. It's no longer linear. So we have an A-shaped chariot to show acceleration here, and then the velocity, V, little like puffs of dirt kicking up, and they're going along the same linear track. So this is just that idea that these things are moving in one dimension.
How about this? I think there was something you mentioned when we were talking a little earlier, Kyle. We had to let you cover this part. What is it about acceleration and the party going on?
Well, so, I mean, we've got a lot of you in here today. There's actually more than 90 people here present for this webinar. So we've definitely got a party going here. And I don't know if you guys know this, but there ain't no party like a physics party, because a physics party don't stop so long as the acceleration stays positive. You
know what? Let's do it. Let's do it for the math jokes. Let's do it for the physics jokes. We got it.
But so the point here is that if you have an acceleration, it is because there is an unbalance of your forces. You have unbalanced forces. There is a net force. And so the second little A-shaped chariot here has a newt who's like falling off, right? He's got a snake pulling in with some serious like steroid use. I think maybe has been happening here. The like anti-doping rules weren't really established in medieval times. So there's a lot of acceleration happening here. There's a lot of forward force. There's more forward force than there is backward force from things like friction or drag. And so there is an acceleration. And this is kind of a very base underlying important aspect of physics, that anytime there's a net force, there's going to be an acceleration. Anytime your forces aren't balanced, there's going to be an acceleration. And this will come back even in this very lesson a little bit later on. But it's just a very, very important underlying physics concept that we're displaying here in a very kind of obvious visual manner, with this newt who is like falling off of his chariot because of the acceleration that's being experienced.
He's lost his balance because of the unbalanced forces.
Totally.
And here we have Hunter. You're gonna have to tell me whether this is a fan or a heckler teaching us our next subject about linear motion.
So that's actually a really good question. I thought we were debating if it's an alligator or crocodile, because I think I have two answers for you. Number one, I think it's a crocodile because it's got a V-shaped nose. All right, number one. Number two, let's just make the whole point moot and put like wings on it, and now it's a dragon. So like that works too. But yeah, let's talk about what this mysterious reptile on the bridge is representing, right? So you'll notice that we're hanging out here. And this is kind of the thing that I love about what y'all do, is that like it's just like every single square inch is packed full of detail, right? So instead of like we have our acceleration with these guys kind of going left and right, these are going straight down, because now we're talking about free fall, right? And we're talking about the acceleration due to gravity, not due to these cool angry worm guys. So we're throwing things straight down. And then I think y'all told me, and my eyes are bad, but if you look here, they are 10, right? Does anybody know in chat, how come they're 10? If we're talking about acceleration due to gravity, what could the value of a 10 cent coin? Oh, look at that. Y'all are amazing. Yes, it's gravity rounded up, because let me tell you what, the MCAT, you got 60 seconds. Ain't nobody got time to work with 9.8. Okay, so it's going to be 10, but we're throwing it in a downward direction, right? So we were going down this way. It's not positive. It's going to be negative. That's kind of the connotation that like we normally write it, as far as like the acceleration due to gravity is going down, so it's negative. One of these days, y'all can get me kind of on a tangent about how everything in physics is just we get to make up imaginary lines, and anything can be positive as long as you do it. But that's for another day. But yeah, that's what this guy is. Downward acceleration due to gravity. Love it. It's awesome. Yeah.
And the reason why they're 10 and not 9.8-cent pieces is because we had to hedge a little bit because of inflation. By now, they're actually 9.8.
Yeah, physics inflation for sure.
So we're moving on now to, I guess I gave a little, I guess by putting an extra click, I gave a spoil as to what this symbol represents. And Kyle, you even teased this like a minute ago, of what we were going to get to. So we've got this fella falling out of the tower, and we got a wizard kind of, what's going on? What is this symbolizing? What can we remember?
Yeah, so here with this next symbol, we're working on representing a concept that's pretty important in physics, the idea of terminal velocity. And terminal velocity is the reason that humans can actually go skydiving and not die every time. The faster and faster you move, the greater and greater your drag is from like air resistance, from friction. And so as you keep speeding up, the drag keeps getting bigger as well. And eventually there is some kind of like magical number, and magical being an appropriate word here for our little image. There's some kind of magical number where your drag up is the exact same size as the actual force of gravity down on you. And now we aren't unbalanced anymore. You're actually balanced, right? When you first jump out of a plane or fall out of a window, there's a downward force of gravity on you that's basically unbalanced, right? Uncanceled, and you start to fall and accelerate downwards. But as you go faster and faster, your drag force upwards gets bigger and bigger, and eventually they'll be the same size. This is terminal velocity. And there's a really important point here that is a little bit counterintuitive for a lot of students. The net force is 0. When you are at terminal velocity, the net force on you is 0. There are forces, right? But they perfectly cancel out. Gravity down and drag up are the same size, but opposite direction. So they cancel out, you add them together, you get 0. The net force is 0. But, here's the but, that doesn't mean you're not moving. Things are absolutely allowed to be moving, even if the net force is 0. You're just not accelerating. And this is another really important point, is that there are kind of like two kinds of equilibrium. Equilibrium is when you have no acceleration. You can be sitting still, right? Like I am right now. And like I imagine most of you are, although I'd like to imagine that at least one of you is like out running through, I don't know, a beautiful park or something and listening to this. But most of us are sitting on our butts in a chair. And so we have no acceleration, we're sitting still. But if you are moving with constant velocity, you also still have no acceleration. And so terminal velocity is an example of what we might call dynamic equilibrium. Yeah, your net force is 0. Yeah, you're not accelerating, but you are still moving. And this is an important point and something that's kind of worth bringing to mind and being aware of. Both this idea of terminal velocity, that as you speed up, your drag gets bigger and eventually it'll equal gravity. And then also this idea that even if your forces are balanced, it doesn't mean you're not moving, it just means you're not accelerating. Yeah, so there's a lot of really important physics in this kind of this tiny little image here of a newt being held up by a newt wizard who gave him a little puff of air to help balance his force of gravity.
Yeah, excellent. And okay, so the rest of this scene that we're setting, basically the whole right-hand side of the image that we're going to get in, all of you here, you knew we were going to cover them, or at least you probably hoped we were going to cover them in the less nonlinear motion. We're going to get to all the equations that you must love, all those 4 big ones, and the best ways to remember them, and they involve velocity raptors. So Ricky, tell us what's going on with this velocity raptor.
Well, this velocity raptor won, obviously. I think he was called Vin Diesel, something related to Vin Diesel at least. Do you want to go to the next slide?
Yes.
Yes, let's get this. Okay, so obviously the kinematic equations are kind of the bread and butter of linear motion, and there's 4 of them, and the one you use depends on what information you're given. So you have to know all 4 of them, have them memorized, so you know which one is appropriate. So our winners and one loser will teach you these. So the first one is V equals V naught plus AT. So that's velocity equals the initial velocity plus acceleration times time. So this velocity raptor, he's got a little V on his snout, and that is the first V, the velocity that we are solving for. And he's making, we've tried to figure out how to do this hand signal. Very difficult.
I think you gotta do it like this way, like hold down.
There was some creative liberty in art there. So that's the V naught. He's got a little plus sign on his chest, and his His trophy has an A on it, and he has a timepiece, or I guess if you wanted to call it a watch, that would be fine too, for time.
Yeah, there's an extra knuckle in the bone, in the thumb. That's what
they're extinct. They're not around to
me a
tell us
second.
we're wrong here. So.
And yeah, Ricky, I think this in the actual sketch is Vin axolotl.
No, that's right.
If I remember the names. And throughout, I think all of our motion sketches, we've got a couple so far, and I think we may have more as well. The displacement is always an axolotl because they've got those fins and it looks like an X, and it's really memorable. So what's going on with this one?
Yeah, so this axolotl is for displacement. So if for displacement, you have V naught, or the initial velocity, times time, plus AT squared, this time, all over 2. So this guy's trophy situation is a little bit more complicated. He's making the same V0, V naught, and also has a watch. And then on his other side, he has an A trophy. He's got a timepiece on his bicep. Again, can't.
As one does.
So long ago, can't argue that they didn't do that back then.
Well, they don't really have thick wrists like humans do, so they got to put it higher up so it doesn't fall off.
That logic checks out fine for me. So that watch is the hands are in the shape of a T, and if you zoomed in really, really close, which you can't see it right now in the zoom out view, but there is a 2 on that watch, and then there is a 2 in the base. So that is for the first equation for displacement.
And what I love about this equation is you don't need to know any velocity other than what it starts at. And that tends to be the biggest flag for problems where you have to use this particular equation, because you can just stick with V naught. Particularly useful in projectile motion, but that's beyond the scope of our discussion today. Equation number 3, I gotta say this one's my personal favorite. I do have a favorite physics kinematics equation. I don't know if it's your favorite, Kyle, but Kyle, tell us a bit about this one, our V squared.
I mean, so what if you're one of those people who just doesn't have time for solving for time? Right? Ain't nobody got time for that. And so there's just no T involved. And so to get to Adam's point of the first one, like which equation you use depends on what you have, or maybe even more importantly, what you don't have. And if you're doing a problem that doesn't tell you anything about time, this might be where you are headed, is this particular equation. It's the only one we're going to see that doesn't have a T in it. And so you can use this even if you don't know anything about time. It's what makes it useful. We have to, again, get a little bit creative with our image in order to make this work out. So this time we are solving for V squared. This is another velocity raptor. She has a V on her snout, just like the first place winner did, but she also has a small 2 next to it. Right, so for each of these people on the podium, the symbol that's kind of on their head is the one that we are solving for, right? So we had just a V, that was it the first time, just an X the second time. Now we got V squared this third time. And then again, we'll kind of use the hands and what's in the hands to be the rest of the equation. So we've got that same impossible to recreate V naught. We have to be like quadruple jointed, right? But now there's a particularly gnarly looking fingernail, right, coming out from the middle digit there that looks kind of like a 2 because it's actually V naught squared, is what is going to be the beginning of this equation. So V squared is equal to V naught squared. And then again, we've got the same little plus symbol on the chest of our velocity raptors. And then we've got a 2AX on the top of the third place trophy. You may not have known this little fun fact. So in medieval times, when dinosaurs ran races and got third place, the trophy would say 2AX on the top of it. Many of you probably didn't know that, but it's true. You can tell from the image right here. So we get our third kinematic equation. V squared is equal to V naught squared plus 2AX.
Yeah, I don't know if we mentioned that. This is actually a photograph. This is not a drawing.
An unearthed photograph that predates by several hundred years every other photograph ever.
Yeah, big news today that we're sharing.
Impressive. Okay.
Yeah, you heard it here first.
So we had a few other folks who were signed up for the race, and I believe canonically this guy, his chariot had to go in for repairs or something, so he's a little miserable. But Hunter, let us know what's happening with this guy with his nice bicep tattoo.
Yeah, he's my favorite. This guy's so adorable. I think actually, what do y'all call him? Dad bod axolotl, right? Like, is that this guy? Maybe.
This
Okay.
is dad bod.
This
Yeah.
is dad bod for sure.
Axolotl.
So I'm into him. So yeah, we're talking about the fourth like linear or the fourth equation for linear motion. This one's a little different. It's dealing with, whereas the other ones are like initial velocity, final velocity, blah, blah, blah. This is average velocity until you sit and you ask yourself, wait, what is average velocity? Oh, you take the start and then the end, and then you divide it by 2, because that's how we find averages, right? Like, you just add them together and then divide by however many. So heck yeah, we know how to do that. So how does this guy represent it? The head is the X, right? And I'm like being really so I'm drawing over you guys' beautiful drawings, but it's just because I am takes me a while to see these actually. I'm really like, I like it when y'all like explain it for me. So we've got the X here. That's going to be our displacement. We have our V, our little hand symbol there, right? And then my eyes are bad. Is there something over this V right here?
He's got a bicep tattoo.
Is that okay? There's the bicep.
It goes all the way around. Look at him.
Well, it goes in the front. We don't know about the back.
I see. Oh, I get it. It's one of those tribal ones. Okay, I'm there for it. No, my eyes. Oh, it's so bad. Anyways, so yeah, the tribal tattoo lets you know that there's like the line over the V, because the line over the V is average velocity. Heck yes. And then again, the timepiece. We're gonna keep hammering. Timepiece is the new way. Well, the new old way to say watch until it catches on again. All right. So don't tell me it's not going to catch on. So yeah, this guy is our fourth linear motion equation here.
Well, thank you, Hunter, for finish things off there. So this is our entire scene for linear motion. Certainly not the last thing we're going to do today, because we're going to apply this in just a hot second. But yeah, we've got the definition of acceleration and velocity, and the fact that for linear motion and these equations, we're talking about constant acceleration in the same direction as velocity. We have our alligator who has very negative attitude, throwing dimes downward, terminal velocity over here, and then of course our 4 equations. And that kind of review actually happens at the end of every Sketchy lesson. You do become a Sketchy member and check this out. You'll see we do a little bit of review. And the way we actually recommend you work this into your studies, and how we've built the kind of platform around it, is you watch the lesson in the first place, which ends up being a lot like what we walk through, just with a little bit less hangout vibes. And I was going to say less dad jokes, but actually maybe there's more
dad jokes.
So only the best that made it through multiple rounds of revision. But then we want you to come back and review using, we've got this review card interface that lets you basically review the symbols and refresh your memory. But then we have quizzes for many of our lessons, as I think most students nowadays, at least in my day, I feel like when I was a student, I didn't appreciate that quizzes actually helped you learn things. But as it turns out, they do. And we have a couple of those today that I'm going to hand it over to Hunter, who spends many more hours a day on average teaching questions to MCAT students than I do, talking through this first question. And then we actually have a second one as well.
Yeah, this is my bread and butter. All right. Y'all are amazing artists and everything, but just give me some gross numbers. Give me a gross question that's an AMC style, and then I'm a happy person. So all y'all in the chat, go ahead and take a couple seconds to read through this. If we look, check it out, we've got the reptilian race. I'm assuming it was the axolotls and all the alligators that we saw before. The winter podium was constructed 3 meters off of the ground after winning said race. Axolotl stepped. Is that a character's name? Did I just butcher that? Is that a joke?
Let's just go with it.
Okay.
I love it.
All right. They stepped onto the podium. I didn't know if it was like a Vin Diesel reference, and I just didn't know the actor.
Assume everything is a Vin Diesel reference.
When you go deep enough, it is. Yeah.
If you believe in yourself, it's it. Okay. So yeah, 3 meters off the ground. They won the race. They're stepping up onto the podium. They're on the podium. They're holding it 1 meter up. They are also themselves 2 meters. How long does it take for it to fall once they inevitably drop it? So I always tell my students one of two things when you are answering questions. Okay. Especially like specifically in physics. Number one, I love to take inventory, right? Taking inventory is awesome. So the first thing I'm going to do, the first thing they give me is some distances all over here. So we have 3 meters off the ground for the podium. And I'm going to add them all together in order to get like the total height here, right? So we've got 3 off the podium, 1 off, or 1 of them off above the head, and 2 of them 2 meters off, not 2 heads, 2 of them, 2 meters off the ground. So all in all, cool. We've got 6 meters, and this is going to be my X, my distance. Fantastic. Let's see. They're asking me how long does it take? So that's my T, right? Question mark. Do I have any other variables? Y'all throw it in the chat. I'm taking inventory. So all the variables that I know for this equation or this problem, I'm trying to. Ooh, yeah, y'all know. Yeah, love it. Okay, so I'm not going to write G for my variable. It's A. That's our acceleration, right? This is acceleration due to gravity. So heck yeah, we've got 10 meters per second squared. Love it. And then do we have anything else? Oh, Mackenzie, you read my mind. Oh, wonderful. We also have V initial, right? V naught, and that's going to be 0 because it was at rest. We were holding it up and then, oh no, we dropped it, right? So it's not like we loaded into a cannon and shot it into the ground. So once we've got all of our different variables here, you just kind of you use your recall from all of the nice memorization tools. You've got your kinematics and you go, which one do I need to solve for T? Essentially, I've got 3 variables. I have X, I have A, and I have V naught. That's more than enough. Does anybody want to, oh, yeah, Kaylee, yeah, we totally can. Does anybody know what the equation that we want to use is? I call, Shivam, are you saying equation number 2? Oh no, I don't know which one is which but I'm going to assume that y'all are getting it correct. And this is the X equals V naught times time plus 1/2. Hello, Mr. Axolotl. AT squared. Bam.
Yeah, it's the one represented by that axolotl.
Yep, this guy right here. Wonderful. So with that, right, we're going to do a couple fun things. We're just going to start eliminating stuff. I'm going to use green so that it's kind of all right. X, we have an X value, right? This is our 6. I'm just going to plug it in. V naught is 0, and anything times 0 is 0. So that's all 0. What is 1/2 of, what's my acceleration? It is 10. So I'm going to do 1/2 times 10 times my time squared. Awesome. Simplify all this down. You can divide your, multiply both sides by 2. So it's 12 divided by 10 in the end equals T squared, right? And 12 divided by 10, last but certainly not least, I'm going to go over here on the purple. Sorry, I have giant handwriting. It's 1.2 equals T squared. Now, a lot of my students would look at this and go, I don't know how to square root this, right? Which is totally fine. There are, like, in my class, I go through a whole bunch of like math critical thinking. I hate saying math shortcuts because like that makes it feel like top 10 tips and tricks and the AMC hates tip number 4, and that's stupid. It's critical thinking, but using math and numbers. So like, that's what I really like to emphasize. So if we're looking at our answer choices, right? 1.2 is one of the answers. Do you think 1.2 times itself equals 1.2? Nah, I'm gonna get rid of that one. Yeah, G-Man, you're right there. How about D? There's a negative value for time. What is negative time? It's Inception. It's McConaughey trying to sell me a Lincoln. I'm getting out of here, right? So we've got 2 of them. We've got 2 of them left. And now, honestly, if you're kind of stuck, and if you've been pretty quick with your math up until this point, and you're stuck on, I don't know how to square root 1.2, that's totally fine. Take your answers and multiply them by themselves, right? 0.9 times 0.9 is like, 9 times 9 is an 18, right? So it's probably 1.8. Let's do, how about, or excuse me, 0.18. And let's do 1.1 times 1.1. Oh, 1, this is 11. This is 0. That's another 11. Oh, look at that. It's 1, 2, 1, 2 decimal. Yeah, it's 1.21. I'll round that to 1.2. Cool, we got it. So we're looking for, B is our answer choice because 1.1 times 1.1 is pretty dang close to 1.2. How'd that feel for everybody? Okay-ish. Do I like doing thumbs up and thumbs down. Do a 6 for a thumbs up, 9 for a thumbs down. We okay? I know nobody really likes, and as much as I like to push it on my students when we're studying for the MCAT. Okay, great. No one really likes to do math, but we're on team not no math, as little math
Think
as
for
possible.
yourself, Hunter.
That's why I
preface with a
preface
good time.
That's why I preface with like people who are currently studying for it, because like out of me and you and like all of us, we're all our opinions are a little skewed because we enjoy this stuff. It looks like everybody in the chat is pretty comfortable with that explanation, though. A little bit of quick, just take inventory, figure out what equation you need to use. These great little, the axolotls are great memory anchors for you to pull this up. And like the less time you spend trying to remember the equation, the more time you can actually spend solving the equation. And like, that's the goal with quick memorization. So I'm gonna get rid of all my scribblings here in like 3 seconds. If anyone wants to take a screenshot, go ahead and do it.
There were actually like a couple questions that came up in the chat, and actually, I wanted to throw it over to the other person here today who spends a lot more time than me helping students with physics problems, which is Kyle, for the questions. One question was, how do you know V naught is 0? And the second question is, why not use x equals VT for this?
Oh, yeah. Kyle, you already did the answer for the x equals VT one, right?
Well, so I just threw some stuff in the chat as well, just so that it's there in both places. But those are both good questions, right? And this will, to answer the first one, how do we know the initial velocity was 0? There's a phrase I use when I teach, which is magic physics words. And you need to be on the lookout for magic physics words. And dropped is actually one of them. And this is a word, right? It's just like a regular verb. You're like, whatever. But no, this is an important word to be used in a physics problem. Because if someone drops something, that's to be distinct from like throwing something, right? When you throw something, it has an initial velocity. When you drop something, it was not moving and you let go. And so anytime you see the word dropped, you should actually get excited because the problem just got easier. Anytime you see the word dropped, it means that the initial velocity was 0, right? Something was being held and it was not moving, and then someone let go. And so dropped is one of these like magic physics words. You'll also like the 2-word phrase from rest is the same thing. If you ever see, something starts moving from rest means your initial velocity is 0. It's very, very useful magic physics phrase. Then as far as the other question, like, why can't we, can we please just use the easy equation? Right, and it's like, no, they're not gonna let you use the easy equation. The x equals VT. X equals VT only works if you actually know the average velocity. In these problems where there's an acceleration, you need to know the average velocity, and we don't know the average velocity. We know the initial velocity, it was 0, but we don't know the final velocity. We don't know the velocity kind of along the way. We don't know the velocity when it hit the ground. And so we don't actually know the V that we need for that particular equation. The only V we know is the V naught, the initial velocity.
That is why the dad bod axolotl had the bicep tattoo, because that line over the V that says average, it really means something. There was also a question of would the numbers likely be this close together on the MCAT? And I don't know if that's somebody who has been to one of these sessions before, when I have said the answers tend to be very far apart on the MCAT. And I will tell you, the answers do tend to be very far apart on the MCAT. But at least the way I think of this one, Hunter, is this is a realistic MCAT question, because even though 1.2, 1.1, and 0.9 are very close together, once you get to that last step where you have to take the square root of 1.2, it can only be one of those 3, because it can't be 1.2 and it can't be 0.9, because 0.9 squared is smaller than 0.9. So it's got to be 1.1. So basically, those answers are a lot farther apart than they seem, given the question, which is why it's pretty clever.
Yeah, normally you can get away with like shooting from the hip and doing really aggressive rounding and stuff like that, because the answers are going to be really far apart. But yeah, like these numbers are pretty simple to work with. So like the AMC might be mean and give you these ones. This would be a discrete. It's not passage based, obviously, but yeah, this definitely is something that might get thrown at you.
There are a lot of MCAT passages about reptilian races.
It's true. The AMC is known for one thing, if anything, and that is their creativity and imagination. So.
We've got another question we can go through too.
Yep. Let's
Michelle
go.
Cretaceous.
Michelle Cretaceous. Oh, see, I'm convinced the axolotl name from the last one, I missed the pun. It went right over my head, and I'm really sad. So we have Michelle Cretaceous here, jumping into her chariot while it was at rest. Hey, there's that magic physics phrase that Kyle just talked about, and drove it in a straight line with a constant acceleration. That is also, Kyle, would you argue that constant acceleration is another one of those magic phrases?
Yeah, yep, important if you see that one.
Totally. So constant acceleration of 3 meters per second squared, reaching a racing velocity of 12 meters per second. How far did she travel to reach this velocity? Same thing, right? This the 2 options are usually take inventory or when in doubt, draw it out. I don't want to draw this one because it's not an apparatus. I'm just going to take inventory. There's a bunch of stuff going on. So let's start throwing in the chat. What are some of the variables that we know for sure here? What's my inventory of our of variables? See, yeah, we've got an acceleration for sure, right here, constant acceleration of 3 meters per second squared. So yep, a equals 3 meters per second squared. This is like a radioactive green. It's aggressive. We know v naught, absolutely, v0. What is that? What is v naught? Zero, at rest. It's that magic word. Okay, so we've got 0 here. We also have VF. So this is the first one where we're given a VF value, and this is going to be 12 meters per second. Awesome. Okay, and then it's asking us how far did she travel? So that is x equals question mark. That's what we're looking for. Now I unfortunately don't have the awesome drawings that Sketchy uses in my classroom. So I teach like mnemonics and other things like that. I call this is an instance for the VAX equation. It's VAT, VAX, and tax. This one, so the reason, if I see y'all in my class, you'll get it. But it's essentially, it's the VF squared equals V naught squared plus 2AX. And the reason why I say it's the VAX, oh, wonderful, there it is. Yeah, see, I'm missing those. But it is V right here, AX, so VAX. Oh no, let's undo that. There we go. So VAX, that's what we're dealing with. And I'm going to do the calculations in blue over here in the left corner, right? So let's just, at this point, it's plug and chug. We've done the hard part, which is what do I have and what equation do I need to use? That is literally the hard part. That's why we need to memorize these. Then you just start plugging stuff in. So VF was 12. 12 squared is 144. Equals our initial velocity was 0, so 0 squared is 0 plus 2 for our just the 2, sorry, 3 for our a, and then x. Awesome. So 144 equals, what is this, 6x, divide 144 by 6, and x equals, what is that? So 6 goes in 14 twice, 2 left over, 24. All right, bam. And then, yeah, look at y'all already predicting the answers. You guys are crushing it. So C, 24 is going to be our answer. So again, once you've got the equation laid out and you know you've got a plan of attack, things fall into place. Then you just plug and chug and whatever. That's quick. We can do that. It's all of the critical thinking and like, what do I need to use to get there? That's usually the tricky part. And so that's why just having like really good foundations of like, what are the equations? Do I have these memorized, et cetera, et cetera. It's super necessary, especially in physics.
And to get back to the question about answer choices being really far apart, this is what we're like. This kind of question is the reason why that tip exists, of like, get ready for the answers to be far apart. Because when I was just following you, Hunter, I definitely just skipped the last step. 144 divided by 6. Well, it's not 12, it's not 48. So we can move on, can't we? And I said I like math, and I even, jumped that far.
Nice. Yeah, y'all are crushing it. I mean, the answer choices normally, the AMC, they're not super benevolent. They give us clues, sure, in the question stems, but a lot of times the answer choices are like common mistakes too, right? Like if you failed to like include the 2 for 2AX, all of a sudden you got B, right? So be really careful. They really like to get us with those.
At this point, literally the next thing that will show up here is Q&A and some discussion. So at this point, questions that you've had building up that you were saving, please put them in the chat, or it's even a little easier, especially given how many people are here, if you put them in the little Q&A widget. If you hit that little Q&A button in Zoom, that you can then put that in. There was one question before I move away from this, though, that I want to answer. I think it came up when the last one was on screen, but it was, are MCAT questions going to be this straightforward? And it's not a yes or no answer. The answer is, once you get to the math and the application, yes, it will be that straightforward. What the MCAT is going to layer on top of this that we just did with these two questions is making the setting up of the situation and the deductions and which numbers you need to use a little bit more mysterious, because you'll typically run into something that involves like an electron moving in some direction and in some big apparatus, and there was a whole passage about it, and there are like 5 or 6 different numbers mixed within that passage, or there are a bunch of numbers in a table in that passage. And so you need to be on your toes enough to know which of those numbers to use, for instance, or to realize that it is a kinematic question in the first place, because the answer choices aren't actually numbers, they're directions or they're positive, negative signs or something like that. And that's why it's really important to do in format MCAT practice and take full length exams. But that's the way that the MCAT will be less straightforward. Once you know how to apply it, though, the equations are the equations, and the math that we just did matters exactly as much, and it's quite realistic. So we've got a couple more here.
We've got several people asking about
go ahead.
Positive and negative with regards to acceleration, which is a very good question, and you want to make sure you get that right when you're dealing with these things. So here's the good news that maybe you won't think is good news, because I'm not going to just give you a straight answer. The good news is you can pick whatever you want as long as you stick with it. This is the important thing for doing any kind of linear motion problem. You can pick whatever direction you want to be positive, whatever direction you want to be negative, as long as you stick with it for that whole problem. So traditionally, the way we usually do things is that up is positive and down is negative, right? That's kind of the most common way to assume kind of a coordinate system. Up is positive, down is negative. Well, in that case, the acceleration of gravity would always be a negative number, right? And this is one of the reasons that we do often think of it as being negative 9.8. Right? If you want to be a little bit more picky, and as a physics professor, I tend to be picky, it's a little bit more accurate to say that the acceleration of gravity is 9.8 meters per second squared down. Down is actually a better word than negative, right? Because that's what it always is down. But if you go with the standard convention of up is positive, down is negative, then yes, the acceleration of gravity is negative. But here's the thing. If you're working on a problem where somebody dropped something from up high and it fell down, like we just did, you might as well make your life easier and actually call down positive in that problem, because everything that's happening in that problem is happening downwards. And so why would you make your life difficult with a bunch of extra negative signs? You could just call down positive, and then the distance would be positive. Because remember, you think about it, we used a positive 6 in the equations on that problem. It was the 3 + 2 + 1, right? The 3 meter podium, the 2 meter velocity raptor, the 1 meter above the head, it was 6 meters. But the direction that the trophy actually traveled was not 6 meters up. It was 6 meters down, right? The displacement was downwards in that problem. So by using 6 and not -6, we didn't realize it. We never said this out loud to you, but we secretly decided that down was positive in that problem, which is why we then used a positive 10 for the acceleration rather than a negative 10. So if all of this sounds confusing to you and you're like, oh my gosh, like I have to decide, I have to keep track, and I don't know what to do, then you know what? You don't need to worry about that. You can just always go with the standard convention of up being positive, down being negative, in which case for you, acceleration from gravity will always be -10. You can do that if you want. If you are able to handle this, this idea of kind of like deciding at the beginning which way you want it to go, you can make the math a little bit easier. You might have fewer negative signs to deal with. But this is another thing, and I say this to my students a lot as well, right? Like there's more than one right way to finish that problem. You can choose either, as long as you stick with your choice. And so if you like the idea of being able to call down positive, do it. If you are scared by having to decide which direction is positive, you got that analysis paralysis, right? If you're like me and you spend 45 minutes deciding what to watch on Netflix and you have to just go to bed because it's too late anyway, then you can just jump straight into it and always assume that up is positive and down is negative. There you go. There's a long answer to a good question.
It was a great answer. Yeah.
The difference between math and physics is, in physics, you've got directions, you've got vectors. Math, you've got positive and negative. Turns out there's no such thing as positive and negative in the real world. There's just directions. And so that's why I really like the framing that you had on that, Kyle, which is that like ultimately there's just a direction something is going in, and you can lay an axis on top of it where there's a 0 point and there's a positive and negative. But if it ever helps to kind of separate those things, then let it help you. Absolutely.
Yeah, I love the concept of negative forces or like negative pressures when you're talking about like breathing in your diaphragm. I had a physics professor when I was very young who told me, Hunter, Negative pressure doesn't exist. There's no such force as quote unquote suction. Suction doesn't exist. It's only pushing or pulling. So do you know what that means, Hunter? And I said, what, Mr. Jacobs? And he said, that means that physics doesn't suck. Stop saying it. Get out of my class. And I went, okay, you got me.
Oh man. There's a question that's come up a couple times that I can also answer just as a mix here of like MCAT versus physics. How much more does Sketchy need to do in order to cover the AAMC? That's been asked a few different times. And that's another one where there isn't a simple answer, because what's on the MCAT is actually much more of a gradient than a list. There are certain topics that are really important. There are certain topics that will almost certainly show up, or that are really foundational for other questions that are likely to show up, or ones that are more challenging, so you really want to know them in case they show up. But then there are other ones that, we call them lower yield, high yield, and low yield, where it's less likely to make the difference for you because it shows up less often. It turns out the AMC list of material is much, much more stuff than they can fit in one MCAT. And so they need to make decisions about the emphasis and likelihood on a given exam that they're going to have. So what we have done at Sketchy since we started making the MCAT course is we have worked from the top down. We have worked from the very top of the highest yield material, and we have kind of worked our way through. I would say we are most of the way down that whole list at this point. So to cover the AAMC, maybe Sketchy would technically need to be 5 or 6 times. It just gets very ridiculous. But to cover what you're realistically likely to see on your MCAT, that's actually what we are excited to be talking about now. Is like this kind of tipping point that we're at right now, like 250, 260 lessons, really covers where that high yield line is. And you'll notice, if you look at the Sketchy program, there are a lot more lessons in biochemistry and biology than there are in organic chemistry and physics and all that. And that's because of where those yield curves go across those different subjects. And in terms of how much of what to learn in those subjects is based on facts and concepts and memorization versus learning a few key facts and concepts that you then apply. Physics certainly falls into the latter category. So even though physics shows up a little less often on the whole MCAT, a single physics lesson like the one we saw today may be one of the more important ones that you'll see because it's such a large pivot point. So we are getting close to the 1 hour point, and I want to stick around a little more and answer at least a few more questions if we can, but I also want to get through the rest of our scheduled programming before we do. So I want to throw a couple things out there. One, we have a Discord that you can join for free, and that's the URL. It's a really cool place. We got a lot of pre-meds there. We got a lot of medical students there. It's a cool community. We got like medical students sort of like giving advice to kind of people who are up and coming. We're on there, and we can, we receive feedback and we answer questions. And we kind of do some beta testing of new features sometimes. So if that interests you remotely, you should really just check us out. It's totally free. Join our Discord, discord.gg/sketchylearning. But now we're going to do our giveaway. So this is what's going to happen. There's a free Sketchy X Blueprint bundle. I don't actually know how we pronounce the X. We just sort of wrote it out. Sketchy by Blueprint, Blueprint by Sketchy. It's whatever it is. And Sketchy and Blueprint. We'll go with that. More of a plus sign, than X. But it's Sketchy's MCAT course and Blueprint's full-length exams. So exactly that kind of pair that you might want to put together if you are putting together realistic MCAT practice with, really solid, memorable MCAT instruction. And we're going to give one away. And what's going to happen is I want you to put in the chat your name and your goal MCAT score. I'm going to give 20 seconds for that to happen. And then I will use a proven, patented, randomized selection method that we use for these in order to select a winner. We'll say 10 seconds left. Woo! Great to see everyone in there.
This is a personal thing, but I'm glad to see no 528s, or at least very few, because like, yes, we all want to get a perfect score, et cetera, et cetera. But like, do your research on your school and figure out like what score you actually want. Cause like, that's, you can work towards it. Sorry. That's my little tidbit there. Okay. All right. All right. You guys rock.
Yeah, and I was just no, it's fine. And if there's another question you guys saw, I will take a minute. I'll take just a second to get this through my randomization process. Or we can just spend a quick moment of silence. There's a question about, are there any special ways to remember these equations, or is it going to be strict hammering till we memorize them? You do just have to know the equations, but if you know the equations in the setting of a reptile race where every equation was one of the racing, just throwing an idea out there, you know, something like that.
For example.
Yeah. A lot less time hammering those things in. All right. I'm happy to announce the winner of our giveaway today is Amrita Sharma. And I certainly hope that you get your goal score that you entered there as well in there. Amrita, congratulations. Everyone here who entered and didn't win, I'm sorry, give away one of these per, but I will say we're going to do these again. So come to the next one, you get a chance, but also you should just check us out. We actually have right now a very generous free trial where for 3 days you get, it's either all or almost all of the material in the course that you can check out. So basically you got a few days to check out whatever your favorite subject is that you want to check out on Sketchy. Just go to sketchy.com/MCAT, or no, just go to sketchy.com, and there's a creation piece. You'll also see it in your email because we're going to email you about this. And create a free trial, check things out. What you saw today is one of, like I said, literally more than 250 of these. So if you thought this was a good time, insightful, multiply by over 250, plus it's really great practice for when you get to med school, and you will definitely use Sketchy because people use Sketchy in med school. It's really, we've done the math on how many Sketchy users there are and how many med students there are, and numbers real close. So you can get used to it now. We will be sending out a recording as well. And we'll be sending a recording in the message we have afterwards. And what I want to do, and again, if you didn't win here, we extended a sale that we had. We had a graduation season sale. So if you get a free trial, you want to upgrade, there is a deal that is still live right now. You put in grad 15, you get 15% off. That also works on the Sketchy X Blueprint bundle. And so that's an even more percentage off because the bundle itself is a percentage off, and then there's the additional 15%. What I'd love to do is just grab one more question before we go. And I will tell you, if we didn't get to answer your question, join us on the Discord and you can ask it there and we can answer it there. Just go to the MCAT channel and you can tag me. You'll see me. My avatar is one of the lizards from one of these physics sketches. Then again, Kyle and Hunter, did you guys handle the rest of the questions? Maybe I'm wrong that we have another one to cover.
I think we got to most of them.
Awesome.
Yeah. I will say the name and the goal score really shoved all those questions up a little bit.
I had to scroll for like 30 seconds to get back up there. Well, hey, yeah, and there was also a question. So here's a couple like practical questions. One was, I don't have a student account, but if I sign up, does it count the same? Yes. You sign up for a free trial. That's the same thing as having an account. Also, how many students have completed the MCAT prep with this program? Thousands. And that's already, this is actually the first big summer season we have had. Last year we were in sort of a beta early release, but this year we're in full release and we got to that real high yield complete level. But already thousands of students have gone through, and there are people who've seen giant score increases, especially those who pair Sketchy with other resources like Blueprint or kind of put together their own prep program, and they have Sketchy play the role that it needs to play. That's really what we've built this for, to fit into whatever other prep program that you have.
Oh, I just thought of, Adam, one thing that Jess would have wanted us to say, which is the lesson that you all just got to see. Like if you go and sign up for a free trial right now, you won't be able to find it. It was a super secret sneak peek that we just gave you for a lesson that actually hasn't even dropped yet. It'll drop next week. So it will be there soon, but just so you know, you got something that nobody else gets to see yet.
So you're saying there's a chance it could be a dragon?
By the time it comes out. Oh, it's already in post-production, Hunter. Go away.
All right. Well, hey, this has been I hope I'm speaking for the rest of the panelists and for everyone here who is attending. I've said this has been a really good time. It's been really fun. Want to go around to everyone here with just some final thoughts. Ricky, I will start off with you. I know we got into the weeds on a lot of the practice questions there and kind of got ahead of things. And I want to circle back to you. Kind of what last advice or final thoughts about all this do you have?
I think just to like not get too caught up on overthinking things. Like a lot of times these questions are simpler than they look initially. All you have to do is, like Hunter was saying, is kind of take stock of what you have and figure it out from there. The equations will do the work for you.
Excellent. That's what the guy who trained me to be a waiter many years ago said. He said, let the knife do the work. That's what he said when we were cutting bread. So let the equations do the work. Kyle, final thoughts?
You came to the right webinar. Physics is obviously the most important part of the MCAT, medical school, and life. It is known. This is the way.
Wow, two catchphrases from two different shows as your sign off. That was smooth. Hunter,
Right.
Final thoughts?
No, just that thanks for having me. This was a ton of fun. Always love hanging out with y'all. We absolutely love doing all these blueprint sketchy things. And yeah, like y'all, everybody who's in the chat right now, everyone that you heard from on the panel, like all of us just really like helping students succeed. So like, yeah, that's kind of the number one thing. So I hope to see y'all in either my class, sketchy things. I hope to see y'all like succeeding, getting your white coats, like long story short.
Yeah, absolutely. And I would +1 to that, Hunter. Again, if you've got other questions we didn't get a chance to answer to, join us on the Discord. Go ahead and ask them there. You can tag me. My username is Gray with an E, literally spelled out. Gray with an E, because that's my last name. We're going to do more of these events. We really love doing these study sessions, so keep an eye out for them as well. You can come back and hang out with us in the future. Until then, I'm Veronica Corningstone. Thanks for stopping by.